Hello everyone, welcome back to the channel. In today's project, we're going to build a real-time clock system using the PIC16F877A microcontroller and the DS1307 RTC module. The entire circuit will be designed and simulated in Proteus, while the source code will be written in MikroC Pro for PIC. A real-time clock, commonly known as an RTC, is a specialized integrated circuit that keeps track of time and date even when the main system is powered off. Unlike software timers that stop when power is removed, the DS1307 contains a backup battery input that allows it to continue running independently. In this project, our system will read the current time from the DS1307 through I2C communication and display it on a 16:2 LCD. The displayed time will continuously update in real time. Before we begin, let's take a quick look at the major components used in this design. First, we have the PIC16F877A microcontroller, which serves as the brain of the system. It communicates with the RTC and controls the LCD display. Next is the DS1307 real-time clock chip. This device stores information such as seconds, minutes, hours, day, date, month, and year. We also use a 32.768 kHz crystal connected to the DS1307. This crystal provides the precise timing reference required by the RTC. A 3-volt backup battery is connected to the VBAT pin of the DS1307. This ensures that the clock continues counting even when the main power supply is disconnected. Finally, a 16:2 LCD is used to display the current time in a user-friendly format. Now that we understand the hardware, let's move on to the source code. The first section of the program defines the LCD connections. Using MikroC's S-bit declarations, we map the LCD control and data pins to specific pins on port B of the PIC microcontroller. This allows the built-in LCD library to communicate with the display correctly. After that, we create 2 helper functions for BCD conversion. The DS1307 stores time values in binary coded decimal format rather than standard decimal numbers. Therefore, before displaying the values on the LCD, we need to convert them into normal decimal numbers. The first function converts BCD data received from the RTC into decimal values. The second function performs the opposite operation, converting decimal values into BCD format whenever we want to set the RTC time. Next, we have the RTC_SetTime function. This function communicates with the DS1307 through the I2C protocol. It writes initial values for seconds, minutes, and hours into the RTC registers. This function is usually executed once during setup to initialize the clock. The communication process follows a simple sequence. First, the PIC generates an I2C start condition. Then it sends the DS1307 write address. Next, it selects the register location where data should be written. Finally, it transmits the time values before issuing the stop condition. The next important function is RTC_read_time. This function retrieves the current time from the RTC. The PIC first selects register 0, which contains the seconds value. It then performs a repeated start condition and switches to read mode. The RTC responds by sending the seconds, minutes, and hours data 1 byte at a time. These values are then converted from BCD to decimal and stored in program variables for later use. After reading the time, we use the display_time function. This function converts the numerical values into strings and displays them on the LCD. Special characters such as colons are inserted between the hour, minute, and second fields to produce the familiar time format. Hour, minutes, seconds. This makes the displayed information easy to read and understand. Finally, we arrive at the main function. Here we configure the PIC by setting all analog pins to digital mode and initializing the I2C module at 100 kHz. The LCD is then initialized, cleared, and configured with the cursor turned off. Inside the infinite loop, the program continuously performs 2 tasks. First, it reads the current time from the DS1307. Second, it updates the LCD display with the latest values. This process repeats continuously, creating a live digital clock system. Now let's see the system in action. When the simulation starts, the PIC immediately establishes communication with the DS1307 RTC. The RTC continuously keeps track of seconds, minutes, and hours using its dedicated crystal oscillator. Every few hundred milliseconds, the PIC reads the latest time information and updates the LCD display. As you can see, the seconds increment automatically, followed by the minutes and hours, just like a standard digital clock. One of the biggest advantages of using the DS1307 is that it continues tracking time even when the main system power is removed. This is possible because of the backup battery connected to the VBAT pin. This project can be further improved in several ways. For example, push buttons can be added to allow users to manually set the time and date. Additional programming can be included to display the full date, including day, month, and year. We can also integrate an alarm function that activates a buzzer at specific times. In real-world applications, RTC systems are commonly used in attendance systems, industrial controllers, home automation devices, data loggers, security systems, medical equipment, and embedded monitoring solutions. And that's it for this project. If you found this tutorial helpful, don't forget to like the video, subscribe to the channel, and leave a comment below. Thanks for watching, and I'll see you in the next electronics and embedded systems project.